The modern world is created by means of precise measurements. Guitar, television receiver, computer, light, color, this room, and even this time. Metrology. This is a science of measurement, studying methods and means to ensure uniformity of measurements and ways to achieve required accuracy. Since a human being have began to exchange or sell the results of his labor, the question arose, how large is the equivalent of this labor and how big is the product presented for exchange or sale? There appear the needed measures as the units of measurements at that time. The first measure of length has become a human being himself. For instance, a yard is the distance from the tip of the King Henry I's nose to the end of the middle finger of his outstretched arm. A foot was equal to the length of Charles the Great's foot. As different people had different size of hands and feet, it was not always possible to ensure proper unity of measurements. The next step appeared to be legislative acts of various states prescribing reference standard units of measurements. Establishment of the first public service of measurements unity in Russia dates back to 1550. The Dwina Charter signed by Ivan the Terrible testifies this event. After the unified weights and measures have been introduced in one state, a trade within the state didn't cause problems anymore. There is a reference standard, there are copies for distribution, there are special verification people, there are verification standards for control. The system works, but how is it possible to trade with other countries? What measuring do they have? Gallon, barrel, bushel? Industrial development is impossible without expansion of foreign economic relationships. So the issue of establishing a single unified measuring system became very acute. The first such system has been proposed by French people in 1791. Having decided to transfer from unstable human values to more fundamental ones, they measured a quarter of the meridian of the Earth passing through Paris, then took the 10 millionth part of it and announced it to be a meter. Then they took the 10th part of a meter, made a cube, filled it with distilled water and announced it to be a kilogram. This is how a new decimal measuring system called metric system has appeared based on two values, kilogram and meter. But only in 1875, a diplomatic conference between 17 states held in Paris, the metric convention was signed and the International Bureau of Weights and Measures was established. Adoption of uniform global reference standards by states is an important stage in the way of scientific and technical progress and multinational integration. Nowadays, it is impossible to arrange modern production without metrology. The state scientific metrological centers in Russia design and keep ultra-precise reference standards of values units. One of them is a three-dimensional measuring machine calibrated by laser interferometers placed in the All-Russian Scientific Research Institute for Metrological Service. With the help of this machine, reference values are being transferred to production plants. Each plant calibrates its own less precise measuring machines in accordance with the reference standard. Reference standards at production place are supervised by special division called Metrological Service. Once a year, all reference standards pass obligatory attestation. The required accuracy at many production sites is assessed by micrometers and nanometers, and only due to the development of metrological reference standards, we can design a reliable state-of-the-art equipment ensuring progress by this. Mapping on the human genome is one of the most significant achievements of modern science. The genetic code of a human being is a chain composed of 3 billion pairs of nucleotides. Each genome contains millions of mutations. Mutations of a genome cause the development of human race, but some mutations can negatively impact human health. It is necessary to find and divide such mutations while reading a genome. Genome mapping is executed by means of special devices called sequenators. Scientists can affect a genome by means of dot medicine. Scientists can affect a genome by means of dot medicine. Such process ensures huge opportunities in the sphere of treating cancer, diabetes, and other hereditary diseases. But whether the sequenator defines genetic sequence correctly, what is the uncertainty of such defining? This is a matter of human life after all. Therefore, each sequenator must be calibrated properly. Ultra-precise reference standard should be in place for this purpose. And metrologists have revealed such standard, which is a short chain composed of 271 pairs of nucleotides, which can be easily reproduced and received in a laboratory environment. Calibration of a sequenator and human genome mapping is still very expensive and rare procedure, but in 5 or 10 years, a genome mapping of each person will become accessible for modern society, which undoubtedly will pose science and public health services on a revolutionary new level, while causing more complex, precise challenges for metrology. Mankind's progress is unthinkable without development of metrology. New and even more precise reference standards, the lack of which makes modern industries impossible, are highly needed for new discoveries. Dmitry Mendeleev wrote, "Science starts with the measurement. Exact science is inconceivable without measures." The All-Russian Scientific Research Institute for Meteorological Service is a legal successor of the Moscow Chamber of Weights and Measures, established in 1900 by Dmitry Ivanovich Mendeleev.